Hey, here we are. It's
Hello.
AASLR again.
It's a
Brought to
great
you
title.
by Antisyphon Training, which there's the link graphic there for that. I'm going to get that right out of the way. Today, we've got Serena here, as always. And then we have our guest, Derek Rook. Derek, who are you for those who don't know you? How would you
I
describe
am.
yourself?
That's a good question. I am a recovering sysadmin that now does offensive security and used to do like a lot of training stuff, but I've been kind of overworked lately. But I think we're gonna get that started soon,
Oh, we're going to change
like
that
in
a
a
little
few
bit.
minutes. Yeah, in a
Maybe get
few
some
minutes.
motivation back into the training.
That's right.
All right.
That's
So,
right.
so what have you brought for us today? It has something to do with file permissions of Linux.
Yeah. So today we're going to talk a little bit about some of the lesser known or maybe taken for granted idiosyncrasies of Linux file permissions. I find that I used to be a Linux sysadmin back in the day, and I think a lot of people today may not know underlying why certain things work, or necessarily specifically like how the numbers work when you're changing file permissions in Linux. Just set everything to 777 and hope it works, kind of stuff. So, want to clear up some of those mysteries, show a little bit of stuff that maybe some people haven't heard of, and
Don't you want
whatnot.
to
So,
apply those permissions to everything in the whole system? Right?
I
Isn't that
did.
how it
I
works?
did. With early in my career, stuff wouldn't work. I'd hit 777, and suddenly things worked, and I just move
Give me
about my
all
day.
the permissions. Come on.
That's right. That's right. Yeah. Super. I mean, like no shade on that though, because that was a significant part of my career, and I think there's a lot of people that probably are still going through that part of their career, and new people every day. So, it's a good
And
thing
then
to
you
learn.
learn. You
Yeah.
learn
Yeah.
why
Yeah.
not to do that.
Right. Exactly.
Yeah, I've done that, not for Linux, but for Mac OS. I've done that sort of thing in a past life with permissions, arguing with permissions on files and stuff.
It's hard. It's hard stuff for sure.
It can be. Yeah, you can get yourself in trouble. All right, so I'm going to turn it over to you, and we get right into it. You need your slides up right now.
Cool. Yeah, we can put the slides up. Sure. Let's do
All
that.
right, here we go.
So, for welcome everybody. Thanks for joining us. This is you're going to get a sneak peek on something I've been working on for a little while now, writing a Linux class that will someday be released whenever I finish it up. But the module we're going to be looking at, I'm just going to take select pieces out of this because otherwise this will take all day. But the module we're looking at is directories and files, and kind of what different aspects of those directories and files, and specifically the file permissions. So to start off with, this may be a little rudimentary for some people, and it may be brand new to other people. But to start off with, we've got what it looks like when you run the ls-l command. And some people might be familiar with this command. If you're not, it really just lists the files in a directory, and then we'll show the permissions. And when we're talking about that, we see that this block right here is the actual permissions, and we'll get into what those mean in just a second. Then we've got the owner user here and the default group for the file here. Okay, and then we've got the file name way over here. Let's decode this like a little bit. Inside this permission block is a series of values. The first value is the file type, and for quote unquote normal files, that'll just be a dash. There won't be anything there, but it could be something common that you'll see is like a D for directory, and you may even see other things like L for links, or sockets, S for sockets, and things like that. But for the most part, you'll see either just a dash or D for normal files and directories. The next one over is going to be whether or not a read bit is set, and there's a few repeating versions of this, so hold tight for just a second, but we just need to cover the foundations. The first R is for read. The next one over is for write. And then the last one of the three is the execute bit. So with these three permissions, we can actually do a lot of really granular stuff about whether you can read a file, whether or not you can write a file, and whether or not you can execute a file. For normal files, this is pretty straightforward. Can you read the contents? Can you write or modify the contents? Or can you execute a file if it's a script or a binary or something like that? For directories, and we'll get to the weirdness of directories in a little bit, and that might be new for some people, but you can get really granular on how things work, because what we have is 3 different sets of this read, write, execute. And if we look, we can see that they're the first set. So after the file type, the first 3 is for the user, and that's this user right here. So in this case, it'll be Rook. The second set of 3 will be for the group, and here that's also Rook. If you're not familiar with Linux, everybody's part of a default group of the same name of the username, and that's why that's set like that. But so we can actually set different permissions for the user that owns the file, as well as the default group for the file. So we can say, well, I as the owner need to rewrite and execute, but the group that I belong to, say developers or QA or whoever needs to use this file the most, only needs to read and execute, or only needs to read and write, but they can't execute it, things like that. And then that last triple there is for other. Now, this is super important. I catch a lot of people either in interviews or just talking to people calling this all users, and it's not all users. It's literally other users. So if you have, for instance, if this first triple set here is just dash, 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 so the owner doesn't have any permissions, but this has read permission, the other side has read permission, the owner can't read, write, and execute, but everyone else can. So there's a very important distinction here that this is other users, not all users.
That could be bad.
Dude, it's, it doesn't come up very often. And what's important to know about Linux permissions is if you own the file, you can change the permissions the way I'm about to show you. But you can just give yourself read, write, and execute. But you may be seeing like, oh, I can't read this, but it's set in all that everyone can read it. And you'll get confused. Other is literally all other users, not the same. It's also important when we get into the changing permissions that you actually use O for other instead of A for all, because it's not A for all, it's O for other. So that's basics, like how you read permissions. Now, I want to talk real quick about how you change permissions. So there's 2 main commands that you'll do that with. The first one is pretty straightforward, which is the chown command. I apologize for these slides. The slides have been written. This module hasn't hit its quality pass yet, so everything earlier in the class is being redone to make it more readable, but we're not quite there yet for this. So I'll zoom in on the screenshot a little bit here to try and make it a bit more readable. But what the chown command does is change owner, and what it allows you to do is change the user and or group of a file. So here we can see that we've got a file that is owned by the test user account, and its default group is test user as well. We can do something like chown rook, and then we put a colon there, and then rook ownership. And what this notation means is that we're changing the user colon group of the file. This is a convoluted screenshot that I'm going to replace, and it's making a point about sudo and stuff that we cover elsewhere in the class, but don't worry about that stuff right now. But what we're doing is we're changing the ownership to rook and rook. And when we look down here after we do the sudo nonsense, you can see that the ownership has changed from test user to rook. Now, you can do things a little bit differently. You can actually omit either side. So if you just put chown and then a word there and no colon, then it'll change the user. If you put the nothing in front of the colon and you do colon and then a thing here, that'll be the group. Okay, so you can actually just change the group ownership instead of the user ownership if you wanted. So that's the chown command. That's pretty straightforward. A lot of people know about that. If you don't, well, now you do, but it's a pretty straightforward command. The next one we'll talk about is chmod, or change mode. And this is the command that lets us change the permissions of a file. And this has 2 different modes that you can operate in. The first one is I think, easier, and a lot of people either use it or misuse it, and that's symbolic notation, where you actually use the letters to change permissions. So earlier I said you've got the default user, the default group, and then other. And so you can use user, or U for user, G for group, or O for other to specifically target specific permission. So if you're using the U, you're only targeting the first 3 permission bits. If you use other, you're targeting the last 3 permission bits. And if you use G, you're targeting the middle 3 permission bits. From there, you have plus, equals, and minus, and that makes it so that you can either add permissions, set permissions explicitly to something, or remove specific permissions. So for instance, we have user is read write, but no execute. And if we do U plus X, that's a user adding the execute bit. And so now we have read write and execute here. It doesn't modify the things that are already there. It just adds the execute bit. If we set something to equals, specifically set it to equals, it'll actually overwrite the permission bits here. So right now we just have the read bit set. We set it to equals write and execute, and then that sets it to write and execute and gets rid of the read. So that's setting it explicitly to something. And then the minus is just the last part of that. So instead of adding something or setting it equal to something, we're just removing. So here we're removing the read bit from the group section. Now, this is all probably mostly review for any of the Linux people out there. What I want to get into is a little bit of the deep magic that is Linux, and talk a little bit about how we set the numbers. Like earlier, we were talking about 777 and like what those permission bits mean. Well, in order to do that, we need to understand a little bit about binary. So real quick, I'm not going to run a class on reading binary, but real quick, if you're not familiar with binary, it's just powers of 2s. So the first place is 1s. So if a 1 is set there, then that means 1. The next set is 2, 4, 8, so on. For permissions, we only need the 1s, the 2s, and the 4s place. We don't need to go all the way up the line. I do this because later in the class we talk about networking, and you need to know all the way up to 256 for networking and whatnot. So we just need the first 3 bits. And so again, if we look at the binary, if you set 1, 1, 1, that's a 1 in the 1s place, a 1 in the 2s place, so that makes 3, and a 1 in the 4s place, so that's 3 plus 4 equals 7. And that's where 7 from 777 comes from. Hopefully, everyone is with me so far, because when you look at something like this, when we're setting 763 as the permissions, all we're doing is each decimal digit is the user, the group, and the other in that order. When you're using octal notation, which is this number notation, you have to set all 3. It's the equivalent of using the equals in the symbolic notation. You're setting the permission bits. So you have to set all 3, user, group, and other.
I'm glad you went over that, because I didn't know what the 777 came from. I thought it had something to do with, slot machines, or, you got the jackpot. You own the file now. That's what I thought it was from.
Yeah, it's the max damage you can do in Final Fantasy VII. It's, it's what you want. It's 777s and everything works. But to do it more precisely, right? If you actually want to get into Linux sysadministration, or you want to get into like Linux security, or even offensive security, you really need to understand what you're looking at, and what different commands mean, and really the integral operation of the command. So to take this one step further, when we've got the 763, that's setting a 7 in the user place, a 6 in the group place, and a 3 in other. Break it down even further. Each one of those is the binary of the 1s, the 2s, and the 4s place. Okay, so Dunderscore Q, that is a perfect question. I'm about to get there. So right now we're just worrying about the 3, and it's perfectly acceptable to just use the 3 notation for now. We'll get into the 4s in a second. So when we break this down, we can see that, and I highlight it here for you, but the 1s place in this notation is the execute bit, the 2s place is the write bit, and the 4s place is the read bit. So we can always think about it. If you have trouble remembering, you don't have to memorize this. This is all in order. So if we look at like this right here, we see that the read bit is the first one, the write bit is the second one, and the execute bit is the third one. So that translates directly to the read bit being the first number left to right, meaning the 4's place, write bit being 2, and execute being 1. So a 6 is setting the read bit and the write bit in that place. Is everyone with me so far? So a 7 would just be 1, 1, 1. So read, write, and execute permissions. Hopefully this is all sinking in. Excellent.
I'm following so far. So you got
Great.
one person.
It always starts with one. That's
Serena's in too.
Excellent. I like it. So this is the basis of that. Like once you understand that it's really just 3 sets of 3 places of binary, and you just know that, you go left to right, read, write, execute. The read places in the left, the write places in the middle, and execute places in read places in the left, write is in the middle, and execute is in the right. You understand, you don't have to memorize anything. You can just kind of rebuild it in your head and say, wait a minute. And it might take you a couple seconds, but it's faster than looking it up. So somebody asked about the 4th digit, because sometimes they are correct. Sometimes there are 4 digits in this permission set. And there's a couple other permissions that I see confused quite a bit. There's a special permission called Setuid, and what that does is it will it'll run, if it's a binary, it'll run the file as the same permission set as the owner of the file. So what does that mean? If we were to if I was to create a binary or a script or something on a computer, and I wanted other people to be able to run it with the same permissions I have, so it needs to read special files that I've created that nobody else has access to, then I can set the setuid bit permission, and other people, when they run this script, will execute the script with my permissions. So a real world example of this, that if you've ever used a Linux computer day to day, you've probably run into, is password changing. So the way Linux systems store passwords is they actually hash the passwords and store them in a file called /etc. To prevent everybody from just being able to read people's hashed passwords and cracking them or changing them or anything like that, the only user that is able to read or write to the file is root. And we can actually look at that when we look at the permissions. We've learned everything we need so far to analyze this situation. So if we look at /etc, we run an ls, we see that the owner, the user, has read and write and no execute, and the group has read, and that's root and shadow group. No one else can change anything in /etc, which means that me as a normal user should not be able to change my own password. I would need root to do it for me. And yet, when I run as test user the password command, I can update my password successfully. How is that? How can we do that? Well, if we look at the password binary, it's actually got the setuid bit set in the user, which means that whenever somebody runs this binary, they're running it with the permissions of root, which allows them to go in and very specifically, under very specific situation and circumstances, change their entry inside of the /etc file. So everybody uses the setuid functionality without necessarily knowing it. There are a couple other specific special permissions that exist. So you can actually do a set GID, and it's really just the same thing. It's just a set UID permission, but in the group's place instead of the user place. If you want to set these using change mode, you can set them using the symbolic notation here. So it's just user plus S or G plus S to do the set UID or set GID permissions. And if you want to do it in octal notation, the way that works is you add a 4th place. So the three that you use by standard, let me zoom in here. The three that you use by standard are the last three. So you can see that I set it for 600, which means that the read and the write permissions, so the first two, the read and the write permissions are set for user. And we can see that read and write are set. And 4 is the set UID bit. And we see the set UID bit set for the user there because we added the 4 on the end. So all special permissions are that 4th digit. Hopefully that covered why there are 4 digits sometimes. And it's very rare because honestly, using these extra permissions aren't used a lot. They're used for very specific circumstances and then not used much else. So a lot of people don't understand where that 4th digit comes from or how that's actually set up. Now, there's another bit of weirdness out there, and it's something that I think corrects a minor flaw in the Linux system permissions. I said before that you can get really granular with Linux permissions, and you can. It seems very shallow because you just have read, write, and execute, and you set it for different users. But as you start using it, it's a very robust system, and it allows you to get super granular. The one problem I have with it is that you can't set different permissions for different users or different groups. You have one user, that's the owner or the user. You have one group, which is the default group, and then you have everybody else. And sometimes I don't want to treat everybody else the same. I want to set them differently. And there is a way you can fix that. There is a way that you can set permissions for more than just the owner, the group, and the everybody else. And the way you do that is with get facle and set facle. So this is get file ACLs, and then there's another command called set file ACLs that you can use. But what it allows you to do basically is set different permissions for different users and different groups. So there's multiple entries on multiple lines for different people out there, for different entities, so to speak. So get facle will just display the permissions that are set. These are in addition to the normal permissions. So you won't actually see these just by running ls. You actually have to run the get facle command. This isn't an offensive talk at all, but I will say from an offensive perspective, I have gotten away with backdooring certain files or maintaining access to certain files by using get and set facle on files, because I think that a lot of admins don't necessarily know about these today as much. They tend to run ls and be like, nope, permissions look good, we're good to go. These won't show up unless you use get facle. So this is a really good tool to put in your tool belt. If you're doing any sort of forensics or administration or anything like that, just check these permissions, make sure they're set the way you expect them to be set.
Yeah, I think this is a great talk. I don't find anything offensive at all.
People generally find me offensive, so.
Well, there you go. You're not offensive right now. You're good.
So the way you set these permissions is with the set facle. So you can either you can use M to modify the extended permissions, or you can use R to set like recursively. So if you want to change the directory and everything under the directory, then you'll use the -R to apply them recursively. You can't have the PowerPoint yet. When this class releases, then the PowerPoint will be part of the class. But I believe
should we maybe
right?
allude to when that might be?
Sure. So, well, I think the recording goes up pretty immediately. But
no, not the recording.
Yeah.
I mean your class. What's the status of this right now?
So the class is in development. It's been in development for a couple of years at this point. Where I'm at now is the class has been written. It's getting its quality pass, and then it needs to be recorded. So I'm guessing aggressively 3 months, probably more realistically 6 months. That being said, It was my intention to have a lab available for download today, and I didn't get it done before the broadcast, but I will have the lab done by the end of the day, and I'll be tweeting out when and where you can get that. And that kind of reinforces some of the stuff that that I'm talking about today, and you'll get to play around with it like on your local machine.
Cool. And yes, the recording of this, it's going to be live for playback right away once this is done, and it's going to be on Twitch. We have Antisyphon Twitch. If you're watching on YouTube, I'll put that link up for you now. We're not, yeah, well, it's not really a link. It's what you can type in to get to the link. And we've got a couple of YouTube channels on BHIS and the Antisyphon YouTube channel. So yes, the recording will be there. You can get some screenshots, in other words.
Yeah. It's that's what I'm trying to zoom in so everything's super legible and whatnot. But yeah, these slides are going to be updated to be better than they are now. So just hang tight. So a couple last things just to wrap stuff up. So there is, do I have that in this? Sorry, I'm kind of skipping around here. Oh, it's after the lab. Okay, so there's a couple special files that we need to talk about real quick. So in the Linux file system, any file that's preceded by a dot is not shown by ls. I am very pedantic about this, and because a lot of people will say that dot files are hidden. They're not hidden. They're just not shown by ls by default. There's no obfuscation or like tomfoolery about these files. If you're trying to hide something like a dot, putting a dot in front of it's not going to do it. In fact, it might call more attention to the fact that dot file is there. But just know that, if you name something and you just put a dot as the first character, then it won't show up in ls. Doc directories are the same, but there are two specific dot directories that you need to know about, and that's dot and dot dot, and that refers to the current directory is dot and dot dot is the parent directory, and those are used for scripting and things like that. Let me find. Okay, so I call out in this module that directories are special files, and this is a super important thing to understand when you're talking about file permissions, because directories are files. Okay. Everything in Linux is a file, and that includes directories. People think of directories as folders, and they're not. What they are special files that maintain a list of the files underneath it. Okay, so the reason why this distinction is important is because the permissions do things that you wouldn't really expect if you think about a directory like a folder. For instance, the read permission for a file or for a directory does not mean that you can just like list everything. It means that you can read the directory file itself. You can get a list of files in the directory, but you can't get any more information about it. So you can actually see this in the screenshot here. We see that we don't have the execute bit set in the permissions here for this directory. And when we run an ls, we can see that these files exist, but we can't get any information. We can't get his permission information, who owns it. We can't get anything more than that. All read does for a directory is allow us to see the contents of the directory file itself, meaning just show us what files are in there. Write allows you to modify the list of files. So you can actually, with write permission, you can add, rename, and delete entries from the list of files in that directory. It requires the execute bit. We'll get there in a second. But what's important about this is that it means that if I have write permission to a directory, even if I don't have write permission to the files underneath it, I can rename those files, I can delete those files, and I can create new files. Super important to understand. So when you're creating, really granular permissions, you need to know how these permissions work. Lastly, the execute bit, you almost can't do anything to directories unless you have the execute bit set for the directory, because what that does is it allows you to set that directory as the current working directory. So in order to read files, to be able to list permissions and things like that, you need the execute bit itself set. So read by itself does almost nothing. It just lets you list the files. Write does actually nothing because you can't set the working directory as that directory. Execute is kind of the god bit of directory permissions. Now, to get back to that fourth character, that fourth digit in the chmod stuff, there's an extra special one that comes with directories. If you think to yourself, wow, it's kind of ridiculous that literally anybody can delete files from a directory, even if they don't have write for that. There is a special kind of bit called the sticky bit that can help solve that problem. And I see sticky bit come up in interviews quite a bit. I don't usually ask about it because I don't think it's that important, but I've seen Fang even interviews talk about the sticky bit or ask what the sticky bit is. So if you want to know what the sticky bit is, what that does is it allows you, it sets the permission so that only owners and root, the root user can do whatever the heck it wants, but only owners of a file are allowed to delete the files inside of that directory. So with the sticky bit set, not just anybody with write permission to the directory can delete files from that directory. Only the owners and the root file can remove those directories. So that's what the sticky bit does. That's all the sticky bit does. And the sticky bit for, do I have setting the sticky bit? Oh yeah, for sticky bit, if you want to set it with change mode, it's ±T for setting the sticky bit in symbolic notation, and it's the one binary in the fourth octal set. So the 4 is, trying to remember. See, I don't even have this stuff memorized. So the 4 is set UID, the 2 is set GID, and the 1 in that fourth place is for the sticky bit specifically. Okay. Lastly, and this is just for funsies, if you want to find files on the file system, I think early in my career I exclusively used locate and slocate because it was easier to understand, and frankly, if you use that tool, I think it's a very useful tool in a lot of situations. But I think I shied away from the find command for a long time because it was a little more complex and hard to understand. But I'm telling you, if you work in Linux every day, it will behoove you to get familiar with the find command. And you can do a lot with the find command without knowing a lot about it. So let's break this down a little bit. The first thing you need to know about find command is that it can be, depending on how you run it, very noisy. So I almost always put a redirect on the end of it. We're not going to go into IO redirection in this class or in this webcast, but if you see this 2 into /dev/null, all that's doing is sending all of the errors that come from a command into nothingness. I just don't want to see it. So that's the first thing I generally do for find commands. The way the find command works is that first thing right after find is the starting location. So I'm going to be searching in this area. It's very common for me to do a / because I generally want to find things on the entire file system. If you know it's in /home, or you know it's in /home/rook, or you know it's in /user/local or something like that, you can put that there. That's just the path to where you want to search inside of. And then the last bit, and you can have many of these, is the search test and the search pattern. So a very common usage of find for me is to use -name and then the name of the file I'm looking for. You can also, instead of using name, you can use iname, and that makes it case insensitive. So you don't have to remember the case of the file you're looking for. But that is a super common find command that you can use just to find a file named or any files that are named that in your search path. And I'll put this up while I'm talking about it, because this can, this is pretty useful for me. And then you can take a screenshot of this if you want. But there's a series of useful search tests that I'll use quite often. So another one that I use a ton is perm. And that one allows me to, in the octal notation, search for very specific permissions. So if I want to look for every file that has a set UID bit, then I can search for dash perm dash 4000 or something, or 2000 if I want to find this set GID bit. Or you can do dash 6000 if you want to find set UID or set GID bits. Another very common thing I use a lot in like either Hack the Box or CTFs or whatnot is you can just do dash readable, dash writable, and dash executable. And that doesn't take a test pattern. All that does is see, am I able to read to it, write to it, or execute to it, depending on which one you want to use, or you can use all three if you want. You can set, if a specific user or group owns it, you can use dash user or dash group. You can do things based on time or size or anything like that. So there's a ton more to find than this, but these are the very common things I use. And if you want to get started using the find command, I think this is plenty to get you started. And frankly, name and iname are a lot for find. Somebody pointed out that locate or slocate needs like update DB or different commands like that. That's true. That's also why they're much faster, is because they're only searching a database. They're not searching the file system. But also I find that find is just much more flexible. You can use all of these search tests plus a bunch more search tests. There's way to execute on finding. So you can do dash exec and then actually run commands based on the different find matching files and things like that. Just very powerful. And now that you know how the permission octal setup works, and you can, you don't have to memorize it. You know how it works, so you can rebuild it in your head. You can use dash perm and things like that to find very specific types of files. So that's it. I usually run over time, but I think we're at like 40 minutes, like just over 30 minutes. So I think I'm doing all right. I think that's the 30,000 foot view of Linux file permissions.
Yeah, that was good.
Was a lot.
It is, but I like a lot of information packed in a short amount of time.
Yeah, I'm the same way. I tend to talk pretty quickly, much to the chagrin of my students.
Oh, I guess I should go back on. Hello.
Yeah, we're on camera now. Look at that.
Hey.
Was there any other windows? You said you had some other windows, or we just run out of time here on that?
Oh, I have a console that I could have brought up, but I mean, if somebody asks me a question that it's easier to show than to, in the terminal, I can bring it up.
All right, so we are at the point where we can take questions.
Yeah, I think we can open it up. Yeah.
So any other questions about what you've learned today? Yeah, let us know.
Yeah, I will say that I do not have all the people that subscribe today. I do have Riznok. I don't think I'm pronouncing that correctly.
Riznok.
But thanks for subscribing. We're actually pretty close to our subscription goal. We only need 6 more. So hope maybe we can get that this week or next week.
Sweet. Lots of good comments from everybody. So they're very appreciative of your little snippet of training. So more Excellent. Motivation to get back into it.
I do need to finish this class. I've been working on it for a long time. So a little bit of information about the class itself. The idea is, it's basically the Linux class that I would want any of my junior OffSec people to know about Linux. The idea is it'll take you from zero Linux knowledge, but some computer knowledge, to about intermediate sysadmin tasks. So not super deep dive. You're not going to learn literally everything or every way to do everything, but you'll learn to be competent in just about every area of Linux, every common area of Linux.
Sweet.
So someday that'll be done.
Cool. And then once again, when Derek does put out his lab for today, we'll probably share that info as well. But if you want to follow him, it is it's right there, right? Your title right here. That's your Twitter username.
Yeah.
So follow him at Rook with those underscores.
With the underscores. Super cool. You know, back in the 90s, everybody's screen name had like underscores and X's on either side of their name.
Super cool. That's how you date yourself. How old you are. All right.
Will the class be on Antisyphon?
Antisyphon.
That's up to Antisyphon. But yes, I believe that is the plan. That was the plan when I started the class a while ago. And I assume that'll still be the case.
I think we'll be grateful to have that on Antisyphon. It sounds like a really good class so far. Slides look awesome. Even in production, the pre-production mode. Pre-production? That's what they call it when cars in pre-production. So I guess
I'll call it pre. I think that fits with it.
Sweet.
All right. So we're running out of questions here.
Any other questions?
If not, we'll probably call it a stream.
I'm gonna go eat some chicken.
Serena's tired.
I'm always tired. I need to go to bed at an appropriate hour.
You just need to not have to wake up at an unreasonable hour. That's
I know. I'm gonna tell John.
You do that. I'll tell him too. Yeah. Listen, guy, I don't mean to tell you how to run your company, but this is how you should run your company.
I'm sure he'll appreciate that.
9 a.m. is too early for kidding.
I agree.
All right. Thank you, everybody who's watching right now and have watched our AASLR, the totally not dry subject of Linux file permissions with Derek Rook. We appreciate your viewership. Yes, like and subscribe, all the things on our YouTubes and our Antisyphon Twitch channel. There's the Twitch one. Again, we really want you to subscribe on that one because we're close to some sort of thing where we get more features.
That partner life.
Yeah, exactly. Or is it partner? Where are we, Serena?
I don't know anything about Twitch.
Oh, I thought you said we were close to some threshold.
Well, it said that we have a goal of 30. I don't know if that's like someone set that goal.
Oh, I don't know. I know nothing. I'm not even logged into Twitch right now, so I don't know. But if you want to find out about our Antisyphon training courses, the ones that we do have available right now, we even have some on-demand courses. It's at antisyphontraining.com. One day you might see Derek's class on there. One day, not so far away. And I am going to hit end stream. We're going to kill it with fire. I have to say those words because Jason's not here. Kill it, Ryan.